Hello and welcome to Tribe Topper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos. In this video session, you are going to learn about the escape velocity. In our previous videos, we have learned about orbital velocity. Orbital velocity was that when a satellite is launched so that it can orbit around the surface of Earth or any planet, right? Like you can see here, there is a satellite which is revolving around, say, assuming this is Earth. So this is a satellite revolving around the Earth. So it was given enough velocity so that it could go and set it up into an orbit. But if we take it to a position, we launch it with such a high velocity that this satellite would not go into an orbit but rather escape all the gravitational pull and everything, and we take it to a point which will be, say, at infinity. So when this satellite reaches here at infinity, that is a point where its total of the gravitational potential energy and the kinetic energy would be equal to 0. That would mean that negative g m by r plus half m v e square is equal to 0, where of course we know g is the universal gravitational constant, m is the mass of the planet, in this case we'll say Earth, and small m is the mass of the satellite, and r is the distance where the total of the gravitational potential energy and the kinetic energy turn out to be 0. And sorry, r is the distance, and ve is the escape velocity, because only if it was escape velocity the sum of kinetic energy and gravitational potential energy would turn out to be 0. So when you equate it with 0, so we'll take this to the right side, we get half mve square is equal to gmm by r, and cancelling out the masses, we have ve is equal to, ve square is 2gm by r, therefore ve is equal to root 2gm by r. So this is the expression for the escape velocity. We can also write it in terms of the small g, the gravitational field strength. So we know that since small g is equal to gm by r square, so if I'll take one r up, it becomes gr is equal to capital Gm by r. So that means this expression can also be written as ve is equal to square root of 2gr. So the escape velocity of any planet would depend on the gravitational field strength and the radius of that planet, the size of that planet. So just to let you know that the escape velocity for moon is so very less that ever since its formation, all the gases and everything escaped because nothing was there to hold it in place. So all the gases escaped from the moon. That's why they say there is no atmosphere on the moon, because the escape velocity was so less that everything escaped from there. If we substitute the value of the gravitational field strength and the radius of Earth, we find out that the escape velocity on Earth, it has a value of 11.2 kilometers per second. That means if something is thrown with a velocity that it covers 11.2 kilometers in 1 second, it will escape the gravitational field of the Earth. So that's all in this video session. In the next video, we are going to discuss a couple of problems on escape velocity and orbital velocity. Thank you.